So we are starting with exercise 14b. Question number 1. Integration of cos 2x upon cos x dx. Apply half angle formula in the numerator. 2 cos square x minus 1. You can also use the other half angle formula for cos 2x. That is cos square x minus sin square x and 1 minus 2 sin square x. But then I feel this one is better because down there is a cos term. Okay. But then don't apply that tan formula over here for cos 2x. Okay. Now we'll split this 2 cos square x upon cos x minus 1 upon cos x dx. So here cos square and cos is getting cancelled, so we are left with 2 cos x minus sec x. 1 upon cos is sec dx. Now this is individual integration because there is a minus sign in between. So 2 sin x minus log mod sec x plus tan x plus c. Okay, so this should be your answer. No need to simplify this further. Second one, integration of sin x upon sin 2x dx. Now sin 2x can be written as 2 sin x cos x. Okay, sin 2x can be written as 2 sin x cos x. So here sin and sin is getting cancelled. So half is outside and 1 upon cos. 1 upon cos is nothing but sec x dx. Okay, so integration of sec x is log mod sec x plus tan x, that you all know. Third question, integration of sin x upon sin x plus a dx. Now if we apply compound angle formula in the denominator, sin x cos a plus cos x sin a, we cannot really split the denominator because something like this cannot be split into two parts. Okay, so for this we require one adjustment over here. Now there is x minus a angle in the denominator, so we'll make the same angle in the numerator. So x plus a minus a. Okay, so I'm making the same angle over here. So if I'm adding a, I will have to subtract a. Okay, upon sin x plus a. Okay, so this is capital A and this is capital B. Sin a minus b, which is the compound angle formula. Sin a cos b minus cos a sin b upon sin x plus a. Now we will split. The first thing will be this upon this, sin x plus a cos a upon sin x plus a. Okay, so that will be cos a because sin will get cancelled. The second thing will be minus in between this upon this. So cos upon sin will be cot x plus a into sin. Now this is individual integration. Integration of the first term into integration of the second term. Sorry, minus integration of the second term. Okay. Take the constant outside. Cos a and sin a are constants because there is no x term over there. Cot x plus a. This is not a constant. X term is there, no? Okay. So cos a into x minus sin a into integration of cot is log mod sin upon d by dx of x plus a, which is 1. That is a chain rule. Okay. So this was question number 3. Let's go to question number 4. Integration of sine x minus a upon sin x dx. So in the numerator, let's apply compound angle formula sin a minus b. So that is sin a cos b minus cos a. A is x and b is a. Cos a sin b. Okay, I hope you know this formula sin a minus b upon sin x. So this will be sin x cos a upon sin x. Okay, so this upon this, so sin will get cancelled, so we'll be left with only cos a. Okay, like the previous problem, minus this upon this. So cos upon sin is cot x into sin a. So this will be individual integration of cos a minus integration of cot x into sin a. So when you do individual integration, cos a and sin a will go outside. Okay, I'll just better write it down. Cos a dx minus sin x. Just a second. Cot x sin a. So this constant terms go outside. Cos a into 1 dx minus sin a outside. Cot x dx. So cos a into x minus sin a into log mod sin x. Okay, that was your question number 4. Let's go to question number 5. Integration of cos x upon sin x plus a dx. So cos x plus a minus a upon sin x plus a dx. So denominator I'm just adjusting in the numerator. This is x plus a, so above in the numerator also I'm making x plus a. But then if I'm adding plus a, I will have to subtract a. So this thing is a and this thing is b. Cos a minus b. Cos a cos b minus sin a sin b upon sin x plus a. Now this thing we are going to split. Achha, by the way, this is plus because cos a cos b plus sin a sin b it will be. So it is cos a minus b. Now this upon this, so it will be cot x plus a into cos a. Cot x plus a into sin a minus this upon this. Sin got cancelled, so we are left with only sin. Okay, so I think there is plus in between. Okay, so individual integration of this first term, sin a goes outside, cot x plus a. Um, I think this is cos a, sorry. So cos a goes outside, and here sin a goes outside. Sin a integration of 1 dx. Cos a and sin a are constants. So this is log mod sin x plus a upon dy dx of x plus a, which is 1. Sin A into x plus c. Okay. Next one, that is question number 5. Integration of dx sin x cos square x. So nothing is there, it means there is 1 sin x cos square x. Now it is 1 sin square x plus cos square x upon sin x cos square x. So this upon this. So sin square upon sin, which is sin upon cos square x. Okay. So this is sin upon cos square x plus the other part. This upon this. Cos square part, so it is 1 upon sin x. And 1 upon sin x, we should write it as the next term. Okay, now this can be written as sin x cos x into cos x. This was taught to you in Indef 1, and this is cosec x. Okay, so now this is tan x into sec x plus cosec x dx. Now tan x into sec x integration is sec x. Okay, and cosec x is log mod cosec x minus cot x, individual integration. Okay, so I've applied the formula for both the terms. Okay, so that completes your question number 6. Let's go to question number 7. Integration of dx upon sin x cos cube x. So I'll just write 1 over here, sin x cos cube x. Now this 1 is written as sin square x plus cos square x upon sin x cos cube x dx. So further, we are just going to write this as sin square x upon sin x cos cube x plus cos square x upon sin x cos cube x dx. Okay, so here one sign will get cancelled, so it is sin x upon cos cube x, and here cos square and this cube is getting cancelled, so 1 upon sin x cos x. So I'll just split this into two integrals, sin x upon cos square x dx plus 1 upon sin x cos x. Okay, so let this be I1 and let this be I2. I think this is cube in I1, sorry. Okay, so I1 sin x upon cos cube x dx. Now the derivative of cos is present in the problem, that is sin. Okay, and it has to be in the numerator. The derivative part should be in the numerator. So put cos x is equal to t, method of substitution, d by dx of cos x dt by dx. Derivative of cos x is minus sin x. By the way, let this be equation number 1, okay, at the top. Okay, so minus sin x, derivative of cos x is minus sin x dt by dx. Okay, so now look at the main part, sin x dx. So sin x dx is nothing but minus dt. Sin x dx will be minus dt, right? So I1 sin x dx is minus dt, and cos cube x, so it will be 1 upon t cube because cos x is t. So minus outside and t raised to minus 2. I1, so minus outside t raised to minus 1 upon minus 1, which is minus minus is plus, t raised to minus 1 plus c, which is 1 upon t plus c. We write c1 because this is I1. Now t is cos x, so it is 1 upon cos x plus c1. Okay, I2 1 upon sin x cos x dx, multiply and divide with 2. So 2 sin 2x, take that 2, so take that sin 2x in the numerator, and you can put this particular 2, which is in green, outside the integral. So since it is a constant, 2 cosec 2x dx. Now integrate this. I2 formula log mod cosec 2x plus cot 2x upon dy dx of 2x. 2x is a linear algebraic term. So this is 2, and this 2 and this 2 will get cancelled. Now from 1, I is equal to I1. The answer for I1 is 1 upon cos x plus c1 plus I2. So I2 is log mod cosec 2x plus cot 2x plus c2. So c1 plus c2 you can write it as plus c towards the end and just mention c is equal to c1 plus c2. So this is how you solve this particular problem. Let's go to the next problem. That is question number 8. Okay. So integration of sin 2x upon sin 5x sin 3x dx. So this 2x can be written as 5x minus 3x. That hint comes from the denominator itself. Understand the pattern upon sin 5x sin 3x. So this is A and this is B. Sin A cos B minus cos A sin B upon sin 5x cos 3x. Okay. So this upon this. I think this is sin 3x. I'm sorry. Yeah. So this upon this. Sin will get cancelled. Cos upon sin is cot 3x minus this upon this. Sin 3x is getting cancelled, so it will be cot 5x. So integration of cot is log mod sin. Okay. Along with the chain rule which is down. d by dx of 3x, which is 3, and here it is 5. So this is your final answer. Yeah. So let's go to question number 9. Okay. So integration of dx upon cos 3x minus cos x. Now cos c minus cos d in the denominator. It's a factorization formula. So this is c and this is d. So this is going to be 2 sine c plus d by 2, 2x, 3x plus x, that is 4x by 2, that is 2x, and d minus c by 2, sine d minus c. So x minus 3x, which is minus 2x upon 2, which is minus x. Okay, and sine minus x is minus sine x. And at the same time, this sine 2x, I'll just write it as 2 sine x cos x, half angle. And this is minus sine x, sine of minus x. So I'll take this 4 outside and this minus sign outside. So it will be minus 4, 1 by 4 outside, 1 upon sine square x into cos x. Okay, sine into sine is sine square. Now this one has to be written as sine square plus cos square. Split and solve after this. This upon this sine square 1. So we are left with 1 upon cos x plus this upon this. Cos square and 1 cos is gone. Okay, so it is cos upon sine square. Okay, I'll just give the hint. 1 upon cos is sec, right? And at the same time, cos upon sine square has already been covered in Indef 1. You need to write that sin x 2 times, sin x into sin x. Okay, and then proceed. You can just proceed with this. Let's go to question number 10. It seems to be a very difficult problem, but then it is very easy. Okay, 1 plus 2 tan x into tan x plus sec x, the whole raised to half dx. Okay, so this half, I'll just take it as root for the entire term. This one is sec square x minus tan square x. I'm applying fundamental identity because all the terms are second tan, plus 2 tan x plus sec x. So this is x square x minus tan square x plus 2 tan square x. I'll just multiply this, plus 2 tan x into sec x. Now 2 tan square x minus tan square x is tan square x plus sec square x plus 2 tan x sec x. Now this is a plus b the whole square, where a is tan and b is sec. So within the root it is a plus b the whole square. So this is integration of a plus b the whole square, tan x plus sec x dx. Integration of tan x is log mod sec x. Integration of sec x is log mod sec x plus tan x. Okay. Now you can also apply log a plus log b over here. Log a plus log b is log a into b. That's how you can just finish off this particular problem. Log a plus log b is log a into, okay. So here you can stop. No need to proceed further. So the next problem is question number 13. Integration of 1 plus sin x upon 1 plus cos x dx. Now this sin x, I'll just write it as 2 sin x by 2 cos x by 2. Okay. And 1 plus cos x, it is 2 cos square x by 2. So whatever I have encircled, I have used half angle double angle over there. Now split this 1 upon 2 cos square x by 2, or rather, yeah, that's fine. 2 sin x by 2 cos x by 2 upon 2 cos square x by 2 dx. Okay, so this 2 and 2 is gone, cos and this cos is gone. So send this cos square up in the numerator, so it is going to become sec square x by 2 upon 2 plus this sine upon this cos is tan. Okay, now individual integration. So this 2 will go outside the integration. Integration of sec square is tan x by 2 upon d by dx of x by 2. So d by dx of x by 2 is half. So this is x, right? This is treated as x. X by 2 is LAT, linear algebraic term. So the derivative part will come in the denominator. This 2 and this 2 is getting cancelled. Integration of tan x by 2 is log mod sec x by 2 plus tan x by 2 plus c. Okay. Let's go to question number 14. Integration of 1 upon root of 1 minus sin x dx. So we have this 1 minus sin x formula, but then it will not really work. You can try this for yourself. Okay. So I'll use complementary angle over here. So it's a better choice. There are multiple ways to solve this problem, but then this is a better choice. Okay. So let this be alpha. Pi by 2 minus x is alpha. Now 1 minus cos alpha. It is 2 sine square alpha by 2. Now if alpha is equal to pi by 2 minus x, alpha by 2 will be pi by 4 minus x by 2. As in you need to divide this by 2 individual terms. Okay. So alpha by 2 is replaced with pi by 4 minus x by 2. So it is 1 upon root 2 into root of sine square pi by 4 minus x by 2. Alpha we just took for our simplicity. So 1 by root 2, 1 upon sine pi by 4 minus x by 2, 1 by root 2 cosec pi by 4 minus x by 2. Now integration of cosec is log mod cosec x minus cot x. So integration of this term will be log mod cosec pi by 4 minus x by 2 plus cot pi by 4 minus x by 2 upon d by dx of pi by 4 minus x by 2. Okay, so that you can do it on your own application of formula. And pi by 4 minus x by 2 is a linear algebraic term. So I could apply the formula and do chain rule. Otherwise we couldn't, or we cannot. Question number 5, sorry 15. Sin x upon root of 1 plus sin x dx. Now the challenge over here is in the previous problem there was 1 in the numerator, but then here it is sin x. So we'll make numerator and denominator same. Okay. Now we'll split and solve. 1 plus sin x upon root 1 plus sin x minus 1 upon root 1 plus sin x. Okay. Now a upon root a is root a by rationalizing. Fine. So this a upon root a is root a. So this is going to be root 1 plus sin x minus 1 upon root 1 plus sin x dx. Okay. So let this be I1 and let this be I2. We'll solve it separately. I1 is equal to 1 upon root of 1 plus sin x. Now here we'll apply half angle because it's in the numerator. Cos x by 2 plus sin x by 2 the whole square. So that is equal to cos x by 2 plus sin x by 2. So cos is sin and sin is minus cos. Cos x by 2 is sin x by 2 upon d by dx of x by 2, which is half, and sin is minus cos. Okay. So this will be 2 sin x by 2 minus 2 cos x by 2 plus c1. So this is your I1. Okay. I2 1 upon root 1 plus sin x. Now this is the previous problem. Okay. I use upon complementary angle over here 1 plus cos. Now let this be alpha 1 plus cos alpha. So it will be 2 cos square alpha by 2 root 2, and square root of this cos square is cos alpha by 2. Now alpha is pi by 2 minus x. So alpha by 2 will be this entire thing divided by 2. So it will be pi by 4 minus x by 2. So 1 by root 2 1 upon cos pi by 4 minus x by 2. I'm replacing alpha by 2. And 1 upon cos is sec. Sec is log mod sec x plus tan x upon d by dx of pi by 4 minus x by 2, which is half, plus c2. Okay, this is I2. So this 2 you can take it over here, and this minus sign over here. Fine. So minus 2 upon root 2 log mod. Okay, this entire thing over here plus c2. This is your I2. Now you can put the value of I1 and I2 in I. Okay, in I. Where is I? Just let me take a look. Yeah, it's over here. Okay, and manage the constant c1 and c2 over there. So c1 minus c2, this time it will be c will be c1 minus c2. So this is how we solve this question number 15. 14 and 15, practice it multiple times so that you will remember it. Okay. So let us continue with question number 11. Okay. Integration of dx upon sine x minus a cos x minus b. Okay. Now first of all, this is a very different type of a problem, right? So whenever this format appears, you have to do something different. So you multiply and divide with, see if it is sine cos and cos sine. Okay, you multiply and divide with cos b minus a. So cos b minus a is a constant. So one of the cos b minus a I have written outside. Okay, so you have to follow this method only. Don't do any other method, please. Okay, sine x minus a cos x minus b. Okay, This is the first step. So remember, if it is sine cos or cos sine, multiply and divide with cos b minus a. This you need to by heart. Okay. So 1 upon cos b minus a. Now this cos b minus a, I'll just write it like this: cos of x minus a minus x minus b. Now, as if you open this bracket inside, if you solve this box bracket, you will get b minus a. So understand this format. Okay. Upon sine x minus a cos x minus b. Fine. So this is a and this is b. Now all these things we did, there should be a reason why we should do this. The reason is now we can apply compound angle formula over here and then split and solve. So why part comes next, why we are doing this. Okay. First we need to do it and then we will figure out why we were doing it. And that we have figured out. The only way over here is to apply compound angle formula and then split and solve. So 1 upon cos b minus the integration, sorry, yeah, cos a minus cos b, cos a minus b is cos a cos b plus sin a sin b, cos a cos b plus sin a sin b upon sin x minus a cos x minus b. Okay, now split this upon this. So cos terms will get cancelled. So cos upon sin will be cot. So 1 upon cos b minus a integration. So this will be cot x minus a plus we are splitting. So for the next time we'll do this upon this. So sin will get cancelled. Sin upon cos is tan. So tan x minus b. Now this is individual integration. Okay, along with chain rule. So 1 upon cos b minus a cot is log mod sin x minus a upon divide x of x minus a, which is 1, plus log mod sec. See, integration of tan x is log mod sec x. Okay, and then you can do log a plus log b is log a into b. Okay, and then sec you can convert it into cos. All those simplifications you do. At least simplify this for next 2 3 steps. Log a plus log b. Right. Question number 12 is of the similar pattern. We'll just discuss it. Integration dx cos x minus a cos x minus b. Okay, now when it is cos, multiply and divide with sin b minus a. See, if it is one sin and one cos sin or sin cos, multiply and divide with cos b minus a, like the previous problem. And when it is cos or sin, multiply and divide with sin b minus a. Okay, upon cos x minus a cos x minus b, 1 upon sin b minus a. Now this part, express it this way: x minus a minus x minus b. Okay, cos x minus a cos x minus b. So this is a and this is b. Okay, so sin a minus b, sin a cos b minus cos a sin b. You can apply compound angle formula, split, and you may solve. Okay, so just remember This I'll give for self study. You can push it further after applying compound angle formula. Only remember one thing: when it is sine cos or cosine, multiply and divide with cos b minus a, and then write b minus a as x minus a minus x minus b, and then compound angle formula. So they can also give you cos sine, same format. Okay. And the other thing is, when it is cos cos or sine sine, we need to multiply and divide with sine b minus a. Okay, and then write b minus a as x minus a minus x minus b. Right. So this two steps you need to almost memorize it, commit to memory, and then use compound angle formula, split and solve. So that is the end of this particular exercise. Thank you.